Hello guys, welcome back. In this video we're going to do one more problem on kinematic equations. Okay, so let's begin. Now the problem states that the car is at rest at a traffic light, then starts to move forward at that very instant, and a truck moving at the constant speed of 12 meters per second passes at that instant. Okay, now the car accelerates at 4 meters per second square. At what time and at what position does the car catch the truck? Okay, so this problem involves two bodies, right? The first body is the car and the second body is truck. Okay, and one body is moving at a constant speed, that is 12 meters per second, while the other body is accelerating. Okay, so we need to draw a diagram first. Okay, so say this is car, okay, and then this is truck. Okay, now this thing is at rest. Okay, and the truck is passing at the very instant where it starts to move with an acceleration 4 meters per second squared. At that very instant, a truck passes by with a velocity of 12 meters per second. So it's starting from rest with an acceleration of 4 meters per second squared, where the truck is having an initial velocity that is 12 meters per second, and it's constant. So initial velocity is equal to final velocity, as there is no acceleration with the truck. Okay, so truck is moving forward with a velocity of 12 meters per second, while the car is at rest and it's just begun accelerating. Okay, now what do we have to find out? At what time and at what position does the car catch truck? Okay, so this thing is gonna move forward with constant speed, whereas the car, although at rest, the velocity of the car is gonna increase with every second as it's accelerating. So at every second, its velocity is gonna increase by 4 meters per second. That's what we mean by acceleration of 4 meters per second squared. That means that the velocity 4 meters per second is increasing by 4 meters per second every second. Okay, so this is the increase in velocity every second. Okay, now so it's the velocity of car is gonna increase, and soon the car is gonna catch up with the truck at some instant. Okay, so we have to find out that distance, this distance. Okay, and we also have to find out the time. At what time does it catch up with the truck? Okay, so let's begin. As we don't know both these quantities, let's just assume the distance to be s. Okay, let's assume that the car catches up with the truck at distance s. Okay, that is the position s, distance of position s. Okay, so after traveling a distance of s, the car and truck are finally gonna be finally gonna be the same position. Okay, after traveling the distance of s. Okay, so let's just divide this problem into two parts. The first part is truck and second is car. what is with respect to truck? For truck, the velocity is displacement over time, right? Because it's constant. The velocity is constant, right? V constant. So it's just displacement over time, and hence displacement of the truck is gonna be velocity to time. Now, what's the velocity of the car? What's the velocity of the truck? It's constant, that is 12, and the time taken will be just t. Okay. So 12t is the distance. Is this distance? So this distance can also be treated as 12t because it's same for both car and truck. Now, what is this distance gonna be with respect to car? For car, there is acceleration, right? So we know the initial velocity for the car, that is 0. Okay. We know the acceleration, that is 4 meters per second squared. We have to find time, and we have to find distance. Okay. Now, if we use the equation s is equal to ut plus half a t squared, s is equal to ut, that is the second kinematic equation, plus half a t squared. Okay. Now, in this equation, we can find out time. We can find out displacement, right? The initial velocity is just gonna be 0. Is just 0, so this quantity is gonna be 0. So 0 plus half into 4 into t squared. So we again have got displacement with respect to in relation with time, same as with this truck situation. Okay, but the displacement is 12t, right? And it's gonna be same for both the objects, because at that instant, the car and the truck are gonna be in the exact same position. So it's gonna be the same distance for car and truck as well, right? So 12t can be substituted over here in place of s, right? So 12t is 0 plus a. So this is just gonna be 12t is equal to 2t squared. Okay. So let's just move this thing on this side. So 2t squared minus 12t is just gonna be 0. So taking t common, you're gonna get, we can just also take 2 common. Okay, so t minus 6 is equal to, now t is equal to 0 or t is equal to 6. What does this mean physically? This means that both car and truck are in the exact same position when t is equal to 0. Yes, of course, that's true, because initially they are in the same position, and then this car starts accelerating while the truck is moving with the same velocity. And also at t is equal to 6, they're gonna be at the exact same position. That's what it means physically, having two roots of this equation. So at t is equal to 6, the car and the truck are again gonna be in the exact same position. Okay. Now the time has been, we know the time now, t is equal to 6 seconds, that's the time. Now we know we have to find out the displacement as well. This we know now, we still have to find this thing, what position. So we know that s is equal to 12t, right? Therefore s is gonna be equal to 12 into 6, that is 72. So after 72 meters and 12 seconds, 6 seconds, 6 seconds, car catches up with catches up with the truck. Okay, that's it. So we have solved this problem. Done. Okay, that's it for this video. I'll see you guys in the next. Okay, see you. Thank you. Also, if you guys have any problems, okay, just put those problems in the comments box, and any problem or any sum, any numerical, right, or any conceptual problem. Okay, just put the problem in the comments box, and I'll reply to you guys as soon as possible. Okay, see you.